We're going to start with a review. Yesterday's review, okay? What we did yesterday, I mean. So let's review. We have this number, and we are going to write the place values for the 1, the 2, and the 3 that are located behind the decimal point. Would you do that in your papers right now? Let's see if you can just do it on your own. What are those place values? What place value is the 1 in? What place value is the 2 in? And what place value is the 3 in? And there's a line above each of them to do that, just like yesterday. Okay, the 1 is in the what place? Tenths place, okay? The 2 is in the hundredths place. The 3 is in the thousandths place. And they all need what at the end of them? THS. They all need that TH. There's a difference between thousands and thousandths. I say I'm going to give you $1,000 versus $1,000 of a dollar. Big difference. Okay, so we have to make sure those THs are important. Okay, so how do we read that number? I don't mean 0.123. How do we read that number? How does it read? Celia? 123 thousandths. Yeah, that's how we read it. 123 thousandths. Okay, good job. So today we're going to be, remember our first learning goal is to be able to round decimals. And I find that students are kind of a little bit haphazard about rounding decimals. Now, if I was haphazard with rounding decimals for your grades, you might end up with a lower grade than you deserve when I say I round up. So you want to make sure that we know how to round correctly. So when we're going to round to the tenths place, when I say to you, or your directions in your homework say round to the tenths place, we're going to use only the hundredths place to help us. We could care less about if there's some thousandths or 10,000ths or 100,000ths. We could care less beyond the hundredths place when we're going to round to tenths. It's like we're going to totally ignore the rest. Okay? So if we're going to round, how do we read that? Carly? 47 hundredths. If we're going to round 47 hundredths to the nearest 10, we are going to focus in on the hundredths place. Would you underline the hundredths place? And the question is that hundredths, that 7 hundredths, is that big enough to round the 4 tenths to 5 tenths, or do we leave it as 4 tenths? What do you think? Is 7 hundredths, that's 7 in the hundredths place, is that enough for us to round the 4 tenths up to 5 tenths? Right? Yes. Okay, when do we decide to round up? Starting at what? When do we decide to round up? Starting at what? Yeah? At 5. So if there's a 5, there's a 6, there's a 7, there's an 8, or a 9, we would say, you know what, I am going to round up. So 7 tells us we can round up. Notice this little squiggly right here. What does that say? What is this? How do we say that? Not equals. Approximately equal to. Approximately equal to. In other words, you're showing that you're rounding this answer, and we're rounding it to 0 and 5 tenths. So in your notes, I want us to make a little note about why we decided to make that. We're going to say underline that 7, a little arrow down, big enough to round the 4 up to 5. Okay? So in our notes, let's have what's our reasoning behind why we said it would be approximately 0 and 5 tenths. Okay, let's do our next number. Somebody tell me how we read this next number. How is this number read, first of all? How's that number read? Hayden? 246 thousandths. 246 thousandths. What did I say yesterday we don't want to use when we say 246 246. We don't want to say 246, do we? Because what does the and stand for again? A decimal point. So don't say the word and unless you mean decimal point. So Kaden said that correctly. 246 thousandths. What place value are we going to focus in on if we're going to round to the nearest tenth? The hundredths. So we're going to underline that 4 right there. And you know what? Right now, we do not even care about that guy. Just slash him out. Just say, you know what? I don't care about that thousandths place. I only care about the hundredths place. And then we decide, is that 4 big enough to round the 2 in the tenths place up to a 3? No. Remember, it has to be 5 or more, doesn't it? Okay, so we're going to say this is approximately, you get to practice your squiggly equal sign, is approximately equal to 0 and what? How many tenths? 2. 0 and 2 tenths. So we're going to go right here, we're going to do the same thing again. Not big enough. To round 2 up to 3. What was in the hundredths place was not big enough this time to take the tenths place and round it to the next number. So again, very important that we understand how to round properly. Anybody have questions about rounding to the nearest 10? Okay, well then let's move on to rounding to hundredths. What do you think we're going to use? What place value would it make sense to use when we're going to round to the hundredths place? Harley? The thousandths. Yeah, we're going to use the thousandths place to help us. Again, we don't care about anything beyond that. We don't care about the 10,000ths or the 100,000ths or the millionths, or we only care about the thousandths place when we're going to round to the nearest hundredth. So that means we're going to go to our number and find the thousandths place and underline it. Well, first of all, somebody read that number for me. What does that number read? What does that number read? Sam? 635. 635 thousandths, yeah, thousands. Okay, so we need to round, underline the 5, don't we? Thousands, okay. So, is the 5 big enough to round the 3 in the hundredths place to a 4? Yeah, so what's our approximate answer? 0 and 64 hundredths. 0 and 64 hundredths. So we're going to say big enough to round 3 up to 4. Big enough to round 3 up to 4. Okay, would you try the next one on your own? If you don't get it right, be ready to erase, okay? Because we don't ever want to leave our notes incorrect. So go ahead, try that next one on your own. Anybody want to volunteer to read the number for us? Okay, Carly, what is it?
0 and 625 10,000ths. Okay. Okay, 0 and 625 10,000ths rounded to the nearest hundredth is, what's your output thing got? Wait. 0 and 63 thousandths. Because the top is big enough to round 2 up to 3.
But we're rounding to the nearest hundredth, remember? So we do not want our answer to be in thousandths. We want our not 0 and 63 thousandths, because that would be rounded to the nearest thousand. So what would it be rounded to the nearest hundredth instead? So you rounded it correctly if I would have asked you to round to the nearest thousand. Derek, you got this for me?
0 and 63 hundredths.
0 and 63 hundredths? Charlie? 0 and 6 hundredths. How many of you want to agree with Harley? I think that's the one we probably better go with. Okay, if we're rounding to the nearest hundredths, which number are we going to underline? Which number are we going to underline? The 2. What about the 5 then? We don't care. We could care less about it. And then we decide, is the 2 big enough to make the 6 in the hundredths place a 7? Is it? No, it's not. So what sign's going to go right here? Approximately equal to 0 and 6 hundredths. So again, let's make a little note here. Not big enough to round 6 up to 7. It's the thought process we're having. Okay, now we're going to open our books to the Apply Skills, Activity 1 on Lesson 8. So when you find it, and tell us what page number it is. Everybody find lesson number 8. We're going to do the Apply Skills. I'm sorry, Sierra, Kate, somebody, what's the page? 2021. Apply Skills, not Skills Maintenance. Which one is it?
It's 22. That's Apply Skills.
Yeah, we want to do the Apply Skills. Okay, so let's do the Apply Skills. So page 22 then is what we've decided, right? Okay. Okay, so I want you right now, and we're only doing activity 1. Let's do the first one together. So we're just doing some practice here. We're going to round our number. Here's our number. Anybody want to read that for us quickly? What does that read? Does that read, Wade? Sierra?
251,000.
251 thousandths. Okay, well, if we're going to round
No, thousands.
thousands. Yeah, it is thousands. You're right the first time. If we're going to round to the tenths place, what number, which digit do we care about? 5. Okay, so we're going to look at that 5 first of all, and we're going to say, is that 5 big enough to make the 2 a 3?
Yes.
Okay, so we're going to say it is 0 and 3, no, tenths. We're rounding to the tenths place. Now we're going to round to the hundredths place, and when we round to the hundredths place, now we care about the thousandths place, which is the 1. Is the 1 big enough to make the 5 in the hundredths place jump up to 6? No, so we're going to say 0 and 25 hundredths. Okay, you do the other 3. The other 3 now. If you need to write the numbers off to the side so you can underline the places and not do the arrows like we are, do it more like we did in our notes. Go ahead. Okay, you can take turns going and putting one answer up there. You take your books with you. Hey, yeah, please. You go and start. You get to just randomly pick one of them. I don't care which one you do. You don't have to do the next one. You can do whatever one you want. Whichever one you're feeling confident about. keep working. Okay, thank you. That's an 8, right?
Yeah.
Okay, that's good. Okay. Okay, if anyone wants to challenge any of these, they can come up and put it beside it in green. Okay, if you want to challenge any of those answers, just go put your answer up there. I just switched the color to green. Don't erase theirs, just put yours beside it. Any challenges? So we don't want, we don't want anybody to be left thinking that they're wrong, or they're right and then they aren't really right, they're wrong. We just want to be nice to them and say, you know what, let me help you here. Okay, so we agree with all those answers. Okay, anybody want to ask any questions about any of them? Okay, then let's go back to our notes. And we're going to the back side. We're on the back side. We are now going to write fractions as decimals with a repeating pattern. What do you suppose you're going to need for this? Calculator. You're going to watch your calculators out. Calculators out. Bringing calculators to class is not optional. Let me say that again. Bringing calculators to this class is not optional. So, I'm running out of patience with it, and what's going to happen very soon is if you don't bring it, nor talk to me about the fact that maybe you don't have one, then you're going to go back to the locker to get it, or to the office to check one out, and bring back a tardy slip. It's going to be that. That's just how it's going to work. Okay. 3/7. Remember to change a fraction into a decimal. We did this yesterday. We take the numerator, we divide by the denominator. What I want you to do right now is I want you to do that on your calculators, and I want you on that first line, I want you to write down every digit your calculator shows. Show the answer that the calculator gives. No repeating bars needed yet. All I want is you to write what your calculator shows when you do 3 divided by 7. I'll put what mine shows, you put what yours shows. This is where you want to make sure you're being really careful writing down exactly what your calculator is giving, okay? So we're there. Now we're going to decide what the repeating pattern is that's going on in this one. What is our repeating pattern? Can we figure it out? Which digits are starting to repeat? Where do they start? And what do you think we can assume the repeating pattern is here? Carly? You can just say the digits.
4 to 8.
Just the 4 to 8?
Yeah, so it repeats in the back.
Well, if it was just the 4 to 8, then the next 3 digits would be 4 to 8. And then the next 3 would be 4 to 8. And then the next 3 would be 4 to 8. So is it just the 4 to 8? No, because not right here, this 5, 7, 1, that's not a 4 to 8. So it can't be just 4 to 8. Okay, right now, because we can't see the full pattern, plus there's one little thing that throws this off. You're gonna need to focus with me. You're gonna need to pay attention here, okay? Look at this 6 right here. That might be throwing you off. Because you know what happens? The calculator only shows you so many digits, it has to stop. And when it stops, it rounds. So like we were just doing, okay, so let's look at this. See, the 8 is in front of it. Let's go back here to this 8. In this spot where we have this 8, right behind it is a 5, and we're like, wait a minute, there's a 6 behind this one. Well, why is there a 6 behind that one? Because the calculator took this 7 and it rounded that 5 to a 6. So we can really think of this particular 6 up here as having been a 5 before it got rounded. Okay? So now can anybody tell me what they think the repeating pattern is in this one? Okay, Harley, you want to try again?
1, 2, 8, 5.
Okay, again, so remember, whatever you think the repeating pattern is, then it starts over right after that. So 4, 2, 8, 5. The next 4 digits would be 4, 2, 8, 5. Are they? Not quite. Katie?
1, 2, 8, 5, 7,
4, 2, 8, 5, 7, 1. And now, if that's the repeating pattern, it would start over 4, 2, 8, 5, 7, 1. This is what our repeating pattern is. That's our repeating pattern. So, a little tricky sometimes to pick it out, isn't it? Some are easier than others. Okay, let's try 4 ninths. You're going to do 4 divided by 9, writing out every digit your calculator shows. And some of us, your calculator may show more digits than other calculators do. My calculator shows it out 10 places. I don't know how much yours does, but just write it as many times as it does. Okay? Write whatever your calculator says.
Mine writes it down 7.
Yours what?
Mine does it down 7.
Does it to 7? Okay, so you can write down 7 of them then. Anybody else? Okay, what's the repeating pattern in this one? What's the repeating pattern in this one, class?
4.
Just 4. Not 44, not 444, 4. The 4 just keeps repeating, doesn't it? So, 0.4 with the repeating bar over the 4 is 4 ninths. Okay, 1/6. Try 1/6. Okay, what do you think? Is there a repeating pattern in this one? Yes? No? Something that keeps repeating and then in a pattern? Harley?
I think it's 0 to 16 repeated.
I think the 16 is repeating. Okay, let's look. 1/6. The next two would be 1/6, are they? No. So this the 16, the 1/6 is not repeating. Ikea? You think you know? No. Okay. I think here's something throwing you guys off. I think it's this fellow at the end here, isn't it? Because what do you think was possibly the next digit? Could it possibly have been a 6?
Yes.
And then another 6 after that?
Uh-huh.
And then what would this 6 do to that 6?
Negatives.
Make it a 7. So the calculator, remember, it has to stop, it has to round, it has to quit showing you. And some people's calculators don't round, others do. Mine does, okay? So there is a repeating pattern. What is it? What keeps repeating? Katie?
6.
The 6. So we would write this 0.16 only repeating bar over the 6, the 1 does not keep repeating. Only the 6 repeats. So we can't put the repeating bar over the 1. So make sure your repeating bars cover as much as they're supposed to, and only that much. Okay? So any questions on those when you have to do those in your homework? Now, if you don't have a calculator and you're not willing to do something about that, you're going to have to do something like this. And you're just going to have to start dividing. And you're going to have to keep going. Okay? So, did I do that right? 1 divided by 6. So it's going to be more painful. I'm letting you use a calculator on it. That's the good news. Okay, this is really important. We have to make sure that we start learning this, and we can have, like, we understand names for numbers. All fractions are called rational numbers. Okay, fill that in first. All fractions are called rational numbers. You are comparing one number to another, ratio, rational. All fractions are called rational numbers. When you divide the numerator by the denominator, like we've been doing, you'll get one of 3 results. You'll either get a whole number. Anybody give me an example of a fraction that when you divide it, you'll get a whole number? Wait. Just a fraction that when you divide the numerator by the denominator, you'll get a whole number. 1 over 1. 3 over 3.
8 over 8.
8 over 8. Okay, let's get away from the same number over itself. Give me another possible one that when you take a numerator divided by a denominator, you're going to get a whole number. Besides a number divided by itself. That always is going to be 1, isn't it? That's a whole number. Okay, so yeah. 4 over 2. What does 4 over 2 divide out to? 4 divided by 2? 2. 2. It's still 2. Okay. So we can either get a whole number when we divide them out, or we can get what we call a terminating decimal. Terminating decimal, in other words, it's not a whole number. There's a decimal involved, but it terminates. What's terminate mean?
Like, you get rid of it?
Like what? You get rid of it, it stops, it ends, it's gone, right? It stops, okay? So can anybody give me an example of a fraction that would give us a terminating decimal? Give me an example of a fraction that would give us a terminating decimal. Let's put an example here for this one. Example, let's do the 4 over 2. Because that equals 2, right? Anybody got an example of one that terminates as it's a decimal and it stops? You would never have keep going on and have a repeating pattern. No ideas? Yesterday's notes, I bet that would help. How about this example? 1/2. What's 1/2? 0.5. Does that 5 keep going? No, it stops right there, doesn't it? Okay. So we can have that possibility. Or last but not least, we can have what was happening up above. We can end up with a repeating decimal. Can anybody give me an example of a repeating decimal that you just happen to know that's not up from above? Don't steal from them. We already know that. And you know its repeating pattern. Katie?
0.5.
Okay, but where does that come from? Where does 0.5 repeating come from? You know what fraction that was? By any chance? Sierra? 1 divided by 2, always isn't that 0.5 and that one stops? Okay, alright. Carly?
1/3 which is 0.3.
Yeah, example. 1/3, which is actually 0.3 with a repeating bar over the 3. That's another repeating decimal that we didn't do up above. Okay, so one of those three possible things happen with those fractions called rational numbers. Okay, now I want you to, this is really important also. What happens when a decimal does not terminate? In other words, it doesn't end. Or it never does have a repeating pattern. Is it still a rational number? No. Now we call it an irrational number. Now we have what we call an irrational number. And guess what? It did not come from a fraction, because remember, fractions are rational. Now I want you to do something in your calculators for me. Don't stop here yet. I want you to tell me, did anybody think they know any irrational numbers? Wait. Well, what's it going to keep going with? 12, 13, 14. Oh, okay. So we're done. No, I'll go with that, except for that, that would be irrational, but I wonder where it came from. And by the way, irrational numbers live on the number line too. Anybody familiar with that number called pi?
Yes.
Does pi ever repeat?
Yeah.
Does pi have a repeating pattern? Anybody got a pi key on their calculator? Press it. Can you see a repeating pattern that's ever starting to develop? Can you find a repeating pattern for pi? Does it appear that pi ends? Does it terminate? Does the decimal terminate? No, the calculator just has to stop showing you digits. Just stop showing you digits. You guys, pi is right back there on the board, that white poster, and it's not even the whole number pi. It keeps going and going and going. It never repeats. It never terminates. It is an irrational number. And then there's a whole bunch of others we can talk about another day. Okay? So, now you may get ready to go to your apply skills. We should go back and finish up that now. So, go to your apply skills page. And we are going to finish activity 2. Activity 2 at the bottom there. It says use a calculator to convert the fractions, write the repeating decimal numbers. Okay, let's get busy and do it. Those of you who don't have calculators, you start find a piece of paper and start dividing. Okay, so when you're finished, you can check out the board and see if you have them correct. smartboard and see if you have them correct. Or challenge me if you think I'm wrong. Anybody want to challenge me in any of them? Okay. So again, as you can see, these calculators, there's going to be times we're not going to use them, but there's going to be lots of times you need to have them. Okay. So when you have finished this and you do have correct answers, your workbook is going to be put away, and I'm passing out the homework right now. Do I what? Two extras. Homework. Yes, thank you. Okay.
We printed the wrong thing for today, we wrote last week, so it's actually me.
You're welcome. Okay, so again, your workbook's when you are actually finished with the applied skills, and there you can go back in the after they go on. And the homework I have written on it specifically which sections you need to show work for. If it doesn't say show work in those sections, then you get to do it right on the worksheet itself, okay? Okay, does anyone need this? Some of you are still using that up there? Okay, I'll leave it up for you. Wade, come here, please. And then Derek, I need to talk to you when you're done. We gotta get this put on your grade sheet, and we have to take care of that.
Yeah,
Staple this like I
can I
asked
come back
everybody
to
to
school
do.
and do all this?
Yep, you absolutely can. Okay,
Or-
sounds good. Thank you. Thank you.
Like, I'm not-
Thank you.